All right, I think that's everyone. I'm not sure if we're going to get any more people. Just going to give a few seconds while I set up here on my side. And we will begin the webinar. Right, good morning once again for those of you who just joined us. Today's webinar topic is going to be on finite element analysis in Inventor Professional. So the title of this webinar is Linear Stress Analysis of Parts and Assemblies in Inventor Professional. Okay, my name is Irshad Hanif. I'm going to be your guide through this webinar. I'm an application engineer in Micrographics, and let's start the presentation. Let me get set up on here. All right. So the agenda for today, we're just going to discuss, okay, firstly, I'm going to introduce myself. We're going to talk about the purpose of this webinar. We're going to do a little bit of theory, just so you guys have a better understanding of what's going on. It is important to understand certain concepts before you move on, especially if it's your first time to Inventor stress analysis. Then we're going to actually discuss Autodesk products and Inventor in particular. And then we'll do a quick live demonstration. And at the end of this presentation, we will have a small Q&A session where you guys can post in your questions. You're welcome to type them in your little chat box there on TeamViewer, or you can email me, and my details will be available at the end. Okay. So, like I said, my name is Irshad Hanif. I'm an application engineer at Micrographics. I have about 8 years of experience. I have about 8 years of experience in this, mainly working with Inventor, AutoCAD, Fusion 360, and as well as software like Volt and other PDM solutions. Okay, so the purpose of this presentation, we're going to cover the basic theory, define some concepts, we're going to build confidence using Autodesk products for analysis, and most importantly, here we want to define limitations of Autodesk products for simulation. Why is that important? Because, well, a lot of times you get asked, okay, I want to do some stress analysis, but I'm not sure whether I need full Nastran or whether I can do my analysis with just Inventor Professional alone. And the explanation for that basically comes down to what type of analysis you want to do and to what extent. And we will explain that after we go through the theory. Okay, so first of all, what is finite element analysis? All right. FEA is a numerical technique for finding approximate solutions to boundary value problems and partial differential equations. Okay, that's a very technical mathematics term. We'll get to simplify it just now. So what it does is divides a large complex problem into smaller, simpler parts called finite elements, and takes the total of those simple equations and it molds that into a larger system of equations. That way you can get a gist of the entire problem. Okay, this with the computing power of modern computers helps you analyze a big complex problem in using small parts very simply, right? This method is called the finite element method, and it uses a variety of mathematical techniques, calculus and approximation theory, and it gives you an approximate answer, and it allows you to create a solution that minimizes error. Okay, so what does that mean in plain English? Okay, because that was a bit technical. In plain English, that means stress analysis is a study of how loads affect physical structures and their components. So you have a simple beam and you apply load to it. How does that material behave, and what is the point where it will reach its yielding point, right? Inventor Professional includes an environment called stress analysis, which uses the finite element method, right? So if you just have a standalone version of Inventor alone without any collection, you have a tool that will allow you to do some stress analysis, right? This is why it's referred to FEA, because it uses the finite element method to do an analysis for you. Okay, so let's take a deeper look at stress analysis. So if you consider a very, very simple situation like a load on a beam, you can see that one end we have here is cantilevered, and we are applying our load onto the one end. Right? We can use software to do this, and we can, punch in our load, and we can find all the stresses. But generally, we don't, because these were theoretically derived from your equations that have been done by mathematicians and physicists and all of these engineers who have developed very clever formulas. It's pretty straightforward calculations. You input your details, and you will be able to find your deflections, your angles, and um, basically your stresses at any given point along the beam. However, right, in the real world, you're not going to be able to do that. There's too many variables at play, right? If you look at things like collisions or motions or other types of uh, advanced analysis, right? There's never going to be, oops, sorry, there's never going to be a simple one-line calculation to get through that. What you're going to have to do, you'll find that the math becomes too much. What you're going to have to do is break it up into smaller pieces and use some sort of software to calculate it. Okay, right. So how does this work in Autodesk software? Well, there's three inputs that you're going to have to need to define, or three sets of inputs that you need to define. The first one is the geometry. So that will be your model that you're bringing in, right? So you'll design your model. It can be a single part or it can be an assembly, but it needs to know what volume, what lengths, and all of that need to be defined properly, right? So that's easily covered by whatever software you use to design your product, okay? The next thing is materials. Very important, materials, because materials, you'll know that plastic behaves very different from rubber, which behaves very different from steel. So those technical specifications about the strength and other properties about the material, as well as things like thermal resistance, etc., they need to be input, right? And the last thing you need to define is the statics of your analysis, meaning which points are fixed and which points are undergoing loads. So they're loosely grouped up as two terms, loads and constraints. Okay, you'll see those buttons in your Inventor or in your Nastran. Right? These inputs can be put into a solver. You'll notice there in my box, I've got two types of solvers. One is Inventor Professional, and the other is Inventor Nastran. Okay. By the way, guys, if you have any questions along the way, you're more than welcome to input it in the chat box below. I'm just receiving some requests here, personally from people that I know. But if you want to ask any questions while the webinar is going on, you may use the chat box in TeamViewer. Okay. So like I said, you put this data into a solver, either Inventor or Nastran, and that solver will do the calculations for you and give you out your results. Okay, but it's very important that you have those three inputs. So let us take a look at the next slide. We'll take a deeper dive into those three concepts that I just spoke about, or those three inputs that I just spoke about. The first one is geometry. So like we said, if we had your very simplified model, what does the software do? It breaks your software down into, or breaks your model down into little pieces called finite elements. Right? So you'll see there each sort of tetrahedral shape is called a finite element, right? And you'll see there's some blue dots there. Each one of those points where those finite elements meet with each other is called a node. Okay, so those become important when you're telling the software where your model is and how you're dividing it up and where certain loads are applied. Is it applied at a specific node, or is it applied across all of the elements, right? These things become important in its calculation, all right? The other thing is you can reduce these studies to line elements where it will take into account, for example, in this example here, you have this beam that can be represented as a line and simply two nodes at the end. Instead of a full 3D shape, we'll know that it is a uniform shape, or maybe it has a uniform cross section, right? You can represent them using line elements. That is an option if you're using frame generator to generate, or you want to analyze frames in Inventor. The next thing is materials, right? So what do we need to know about materials? I know this looks a little bit intimidating, but it's pretty straightforward, and most of the inputs are already there. So in order to do any kind of calculations, you need to know your I see a question coming in. Do you offer courses of training on Neston? We do, but I will speak more towards that, more about that towards the end of the webinar. Okay. Right. So we need to define certain things for the material. So luckily, Inventor has a library of materials with all of this information populated in, right? One of the most important things you need to define is your Young's modulus. That's the definition of that being your stress over your strain. Okay, so you can see here I've got a graph and it's just strain, very complicated. But what you need to know on this little graph is that, can you see the first region from the 0 point to point B? That's basically your elastic region, meaning that your deformation up until a certain stress at point B will be elastic. You can bend it and it will revert to its initial shape. It won't overbend and deform permanently. After point B is when it reaches its yield stress, and it will start to deform permanently. And you can see from the graph that once it starts to deform permanently, the calculations change very, very differently. Okay, so you'll get totally different results. Now, I've made 2 points there. Inventor Professional stress analysis only deals with the elastic region, meaning that as long as the stresses that you're dealing with are below the yield stress at point B, right? You can use Inventor Professional. If you are dealing with, or if your loads are approaching stresses that are higher than the yield stress at point B, you're going to need to use a more advanced software like Inventor Nestra. Okay, so that's basically what we wanted to lay out with this slide, or we wanted to cement that idea. Okay, so how do you know what your yield stress of your material is? Well, luckily, these are known things. You can look them up on the internet, but the material library in Inventor will have this information populated. It will have your Young's modulus, it'll have your yield stress, it'll have your ultimate tensile stress. You can see on the graph there at near the plastic region, it reaches point D, ultimate tensile, then it starts to neck, and at point E, that's when the stress or the loads are too much and it starts to break completely. Okay, which is what we don't want. We should never be reaching that point in our calculations. It means you severely under-designed your part. Okay, the other thing that you will need to input is Poisson's ratio. Again, for all the materials, you don't need to stress. They are included for basic materials in Inventor's library. However, you may need to input density if you consider gravity loads, and you may need to input these things manually if you're working with a completely new material. Let's say you're working with a plastic, a specific type of plastic that has a specific density and a specific strength. You need to get that information from the manufacturer or from the scientific data sheet for that material. Okay. And yeah, like I said, Inventor has this included. Well, some of the information included. You don't need to worry. Okay. And lastly, the loads and constraints. Whenever we're doing an analysis, we need to define our scope. We need to define what area we're talking about and how we're going to set up our statics for the problem. Remember, so if you look at this picture here that I have, if you are analyzing a crane situation, you do not need to model the entire crane or even consider the entire crane if all you want to know is how much can that beam of the crane handle. You just need to isolate the arm part of the crane, and you need to apply a certain constraint on one end, a certain load on one end, and the software will have enough information to calculate these stresses and displacements on that situation. Okay, everything else will be irrelevant for the type of results we want to know. Okay, I'm just going to go to the next slide. Right, and lastly, the solver. So the solver is the tool that puts it all together. So in this case, we're talking about Inventor Professional. It puts all the pieces together. It makes use of vectors to interpret the directions. So you can have a load. Let's just say, for example, on the screen, it's approaching 50 degrees from the vertical, 30 degrees from the horizontal, etc., etc. That's what they mean by working with vectors, right? Because it has a magnitude, 9,800, and a direction in your principal axes, X, Y, or Z, okay? Right? This analysis, like we said, because it's that elastic region, let me go back a few slides just to reiterate that. What is a straight line? A straight line is just something f is equal to kx. That region from 0 to b, that's what we're talking about. It uses Hooke's law. So there's some constant there that it would use to calculate based on that a straight line area of the graph. Okay. So what does this look like in Inventor Professional? We'll do a small demonstration now. And I'm just going to start up my Inventor. Basically, what we're going to do, I'm going to show you with a brace model how it's going to look, and we're going to start doing an analysis on that. So let me just change over to the screen. I should probably just bring my Inventor in there. There we go. Let's see. I should probably just change the presenting screen. That's better. I think you guys should be able to see now. That's good. Right. So if you guys can't see my screen, just let me know and I will just make some changes. But from what I can see, everyone should have my model visible. Okay. So you'll see that I have Inventor open with my model. In order to get to my stress analysis, I'm going to go to the environments tab, and you'll see that I have the stress analysis button, right? Like I said, if you have Nastran and a PDM collection from Autodesk, you can install Inventor Nastran, which will take you to a totally separate environment. But for now, our topic for today is just discussing the stress analysis. Okay. Now, this is just to show you how we're going to do it with a part. And then afterwards, we're going to take an assembly and we're going to show you the differences of what you need to consider when you're working with assemblies. This is just to drive the concept of creating a study using Inventor stress analysis in a single body. Okay, so I'm going to create a study here, right? And I'll be greeted by this dialog box. Oops, it's not allowing me to move here for whatever reason, but I think you can see that, right? When I create a new study, it asks me what type of analysis, and I have two options, basically a static analysis or a modal analysis to deal with frequencies and vibrations. Okay? I want to do a linear static stress, so I'm going to be able to either choose that or that, right? I'm going to be able to define certain definitions here. So I can say detect and eliminate all rigid body modes or not. I'm going to leave it not detect because it's a fairly straightforward single body part, right? You'll see that those two are great off because these two apply to assemblies. It talks about separate stresses across contact surfaces. Contact surfaces mean, for example, if we had a bolt in there, there's going to be some points that are touching, and how it's supposed to treat those surfaces that are touching each other. Is it supposed to treat it as one part or two separate parts? Do they slide? What does it do? So in this case, it detects, rightly so, that this is a single IPT, nothing's in here. So it doesn't give me those options. Okay. I'm going to leave it as is, and I'm going to say, okay, I'll give this a name. Actually, I'm not sure I'm not able to change anything. Something's stuck on my side. I'm just going to say, okay. So you'll see that I'm starting my first static analysis, right? And in this browser tree, I can see my model, right? And all the different extrusions that I have. If it was an assembly, I'll see all the different subparts and assemblies in there, right? I have space to define my material, my constraints, my loads, and any contacts, right? And then I'll be able to generate a mesh. So remember we said we've got those 3 important bits of data that we need to input. So let's start. So materials. I can assign a material to this, right, using this browser window here. So I can say this particular material is as defined, or I can choose a material from here. Excuse me, something is just not right with my windows here. I'm just gonna, right. So for example, currently says generic, but if I wanted to say that I want to do this analysis if this was a mild steel part or I think it's called steel mild. Let's just go. If I double click on that, you'll see that I have this little identity box. It talks about appearance, which is not too interested in, but we're more interested in here, which is the physical properties. And this is what I was talking about in my presentation. So you'll see here that I have my Young's modulus, which is important to calculate the strength. I have my Poisson's ratio and my density, etc. Right? If you were creating an analysis using a brand new material, you would have to create a material in here. Okay. Something's just gone wrong here with my windows. I'm just trying to fix this quickly before I continue with the webinar. I think it's just a situation where my presentation is getting in the way of okay. So I will be able to choose, okay, I'm not going to be able to fix it. I'm just going to carry on as is. Okay, something's definitely wrong here. I'm not able to select anything for let's try stopping the presentation quickly and see if I'm able to. Nope, that's not right either. Well, I can't seem to, I do apologize for this. There seemed to be something wrong with my window during the live presentation. So I'm just going to okay, I seem to somehow have managed to change it. It wasn't, there's something interfering in my display, but not to worry. I've managed to define a material, okay? So I couldn't exactly show you how to create a custom material, but if you need to know, you can just contact me and we can go through it. Right, the next thing I need to define is my loads and constraints. So I need to go in and define basically that I want to have those 2 points fixed as my fixed constraint. So you'll see that I have the option here, fixed constraint, and I can choose exactly where I want to fix these things. Very quickly and very simply, you can see these windows are still giving me a problem. I'm going to say, okay, so those two, you'll see a little clip there indicating that they are fixed. Okay, my loads, I'm going to apply a load down the center of this to simulate some compression load on this. So I'm going to add a load. You'll see my load area here. Now you'll notice there's also a button here for gravity. So if this was a really large part and you wanted to simulate the effects of gravity, which can become relevant sometimes if it's significantly heavy and the weight of the part itself comes into play, you'll be able to add the gravity load. In this case, I'm not too interested in that. I just simply want a force that's acting down there, and I can say use vector components to tell it that in my y direction, so I'm going to do a negative y direction. I can say, oops, yeah, there's definitely something wrong here with my I can't seem to change anything. Let's see if I can do this. No. Let's see if I can. Yeah, it is. Sorry, I do apologize for this. There seems to be something just not allowed. Perhaps I should restart my Inventor. Not a problem. Yeah, there's just something that's not quite right during this presentation. I'm gonna start that again. As you can see, none of my windows are just behaving the way they should. Yeah, it's not allowing me to do anything. Okay, I'm going to restart my Inventor quickly. We will continue with the webinar.